This is fascinating. In the ancient days, organisms only made progesterone and progesterone from cholesterol. Just enough for basic signaling. Then, as we evolved, we moved toward internal fertilization, and timing became everything, so we split up into two jobs. We got LH and FSH. We made LH, which hits the theca cells, which takes the cholesterol, and then thanks to desmolase, makes androstenedione. And that is the final product. There's no need for estrogen there. And then you go to the granulosa cells, which are activated by FSH, and they bind to the GS-coupled receptor, increase the CAMP, and activate the PKA and crank up the aromatase. That aromatase takes the androstenedione and it converts it into estradiol. That's the estrogen that you need to grow the endometrium and trigger the LH surge. So why do we have these two separate lineages, these two separate lines? Well, to make the most of our mature follicles, getting both the LH and the FSH signals and produce estrogen to ovulate and prepare the uterus only when you need to maximize fertility. Because back in the day, they went together, and now they can fire separately thanks to evolution. So here's the high yield kind of lowdown. We have theca cells plus LH. Theca cells plus LH is going to make our androgens. And then our granulosa and our FSH will make aromatase and create estrogens. So that's pretty much it. So let's look at this practice question. 24-year-old woman is undergoing ovulation. Stimulation of which enzyme in the granulosa cells is most likely responsible for the increased production? That would be the aromatase. FSH stimulates aromatase in the granulosa cells, converting testosterone into 17-beta estradiol. And that's a key step in the estrogen biosynthesis pathway. Here's some other trap answers. 17-alpha is maybe a little bit more high yield. That acts earlier in the adrenal sterogenesis, is not relevant for ovarian. And cholesterol desmolase is stimulated by the LH in the theca cells, your theca cells, and that catalyzes your cholesterol into progesterone and is upstream the granulosa cell function. All right, so that's a little bit about evolutionary history. I think it's so important to know that every single aspect of the human body is enshrined in, a million-year, billion-year history of evolution. And it's just so interesting to think about these chemical cascades from an evolutionary perspective. That's all I got. If you enjoyed this, like and subscribe.